Oh, okay. So this is recording. It's a recording that's neon pink, neon pink, neon pink. Don't mmuko as mmuko as holo XS holographic vision, holovision, holosight, not holovision. Okay. Um. Today's date is 22nd of January 2026. The time now is 1:32 a.m. 1:32 a.m. But literally the 1:32 a.m. This video is on a new one pink. This is on radiography. Radiography, my version of radio using only radio waves to literally um, literally radio is literally use it for radio internet, radio over the spectrum of red, green, over the visible light spectrum, and everything in between that. For the applications of radio waves via NCK protocol. Obviously, says constitutional framework influence policy. The constitutional, I declare now thoroughly, the constitutional framework of obedience is bound to bear responsibility, bear from, so because I'm from, bear means take, bear means come, BIA, B for Bravo, I for Indigo, A for Alpha, means come, F for France, R for Romeo, A for Alpha means take. BFM come in Nigeria, because for me, I made a constitutional framework for me, not for you guys. So, it's down to me from where I'm from Surrey, where I'm from, because I remember where I'm from. Maybe you guys can do your own, but that's just for me for now. Because I don't trust for me forever. For now, if forever, I don't trust you guys. I never did, and I never will do. That's it. So, obedience continuity of Roger. So, the problem here, I'm getting here for myself, is very important to identify because I saw the problem very well. I believe I need a medal, but it is not a bureaucratic system. It is a no long visit. So this document I got here is what you've been working on, but I've been working here for a little while. So I'm saying, but this is basically how to make neon pink as a color spectrum using radiography imposition. So basically, it's not complete because people's run out, but it is complete when I speak about it. So this sheet of paper, I'm currently in a computer room, is basically a radio neon pink, red, green, blue, alpha. Over Lapis integration or Lapis calculus, which is the Flamoc, is always different Lambda calculus framework. But let me start without getting too into it. So here you got the CYMK color value, where K is the key and B is the black. I believe yes. CMK. This is defined as a vector, the ratio of the key, the color key to the color opacity or darkness as an opacity of theta. Theta. So this variable is called theta, and this theta determines whether we but this is a theta. Theta is just like a symbol is the input vector between the color code of black and key. For example, if the key is 2 to 1, then three-quarters of the color is color of the key is light. Light is the color is seen in that spectrum over pi r squared over 360 and 2 pi r over 180. So that's just different one. 2 pi r over 180 and pi r squared over 360 because pi r squared to do with area, um, pi r squared to do with area, and 2 pi r to do with perimeter, not area. So you can invert that to 1/4 to because the key is color key and B stands for black in the CYMK color model. But you can define it again as RGB. RGB. So the color key of pink as an RGB value is 255, 182, 1933, and theta. Theta defines the opacity. Now, theta is not a Swiss number. It's a vector. A vector is in the vector itself. Theta is the color key and the blackness of the color between 0 and 1 as the ratio. But this can be a three. Basically, if you're using 2 dimensions, you can use a 2 dimensional. But the goal is to have a 3 dimensional isomorphism, of projection. You know what I'm saying? So you can have a 3 by 3 vector, 3 to 1, row 3, column 2 vector, So you go to the one picture. So define data as a color filter that mixes. Basically, it's like a polar color filter. Basically, if you don't know the polar color filter, they are just like the quantum version of the thing. You can see something from an angle. But you know, if you know if you've done it on the right site, this is a security principle, and you can sense. I'll come back to that later. But the goal of this is if I have a finger is basically I have a twin brother. Twin brother can log in my computer, then this was filming. But because it comes time, so you have to acknowledge so. What this does, so the color filter is like a polar of a quantum filter that with conjugate rules that shows that there's like a dip in a sheet in sheet of pink sheet of a pink sheet of paper in a pink pasta and making it pink neon because the neon I'm trying to clean neon digitally without any additional measures because neon is a color that can be computed in real life neon hue neon light neon because neon is just a hue saturation and value that can be mapped to pink. The map is open. So we can use the dynamic table to tabulate and cover and build this up. So we just determine what the color quantization filter between 0 and 1 has the ratio of HSL to determine how the system projects or displays neon based on light intensity and darkening, which is the K and key filter. So how I've done this is this. So So this is a color theory model here. I'm using color theory to do it. But color theory. So I've got so the color theory here is we go to mixes here. 1, 2, 3, 4, 5, 6, 7. I've got this thing here now. 1, 2, 3, 4, 5. So as I do this here, I've used pi squared over system. But pi squared over 3 requires a ratio. And the ratios are pi over 4 representing 90 degrees, pi over 3 representing 180 degrees, pi over 2 representing 270 degrees, and pi over pi, which represents 260. As you can see, this ratio is basically the pi over 2, but this is 90, 180, 270, and 260. But how that came to be was because of the kind of encoding structure behind the system via the luminosity. Now, they share a luminosity which is not the color, or which is not the opacity. Luminosity is not opacity. So opacity determines how bright, how something looks in the dark. Of luminosity to do how bright it is, given the kind of ratio it really has. So luminosity is really how bright. It's not really it's luminous. It's how much you can see from it just by looking at it. Because opacity of something to do with opacity, the hue is different, and either the hue, the value, or the value HSV or HS value alpha or HS H or the lightness of it is different, and that's basically the difference with the lightness and opacity and alpha channels are basically additive additive colors to the model or subtractive color model, and that's how depending on the model. We use the data diagram to model the ratio here. So I've been on the website and I can't remember what's the name, but the neon pink is formed when you have the quantum filter pi over 4 times pi over 4 in radian times the system. So what's the system here? Where we go? So over here. I've wrote it down here. So here, so we've got pi over 4 here. Pi over 4. Pi over 4 times 20.5445 determines the kind of color system that color system. 20 divided by 5445 is basically 20 divided by 5445 is basically the pastel pink. So pastel pink is two colors. So the two colors you need are pastel pink and pink. Pastel pink has a HSL of 346, 191. Okay, 346 is the hue, 100 is the saturation, and the lightness the lightness is 91. So the notice is 88. The notice is 88. And like you can see here, this is just our pastel pink. Pastel pink is more luminous, you can see, but that is the opacity of pastel pink and pink are different. So if you get regular pink, which is standard pink, that can then that's luminance is 84, and the luminance is 84 because that's the ratio to share. So 84, they share four units of difference and similarity, over additive and similarity. So 4 plus 4, you can go from positive 4 from the velocity of ping to go up to so the ratio is 0.4 4 units they share 4 units of similarities and differences. So neon, you can make neon with these two colors because the pastel is like a pastel paste, and the pastel paste can determine how much, basically depending on the polar order, how you do it. So if you have the pastel bucket, you can determine how the pastel will flow through the system. So you get pastel here. This is a pastel pink pastel pink drawing, and you dip a sheet of paper in pastel pink, white paper, pie paper to start with, and you dip in pink. The more pink, the more you dip it. So you go white paper, sheet of paper. The more you dip it, the more pink it gets. And the more time you have to dip it, the more pinker it gets. You know what I'm saying? But the paper shouldn't wear out, tear out. So I wrote white there, but it's pink. But it becomes pink in the end because you get some hue, such the additive model. Giving the more time you have, the more you eventually become pink, and you cannot take the pink off, become pastel pink. Or you can go the other way. You can start from pink. You can start from pink. You can start from just pink, a pink pastel, pink without a pastel, which is just a sheet of paper, and then dip it in so you can start with the pastel pink or sheet of the pink pastel pink or sheet, and dip it in pink, in white, and dip the pastel in to remove the color to get neon. So the goal is to have a neon, a glowing hue, something that represents. But it has to be wet. It's basically it's water. It is water. The neon, the pink of the in the pastel, it's not pastel pink, just the pink, can determine the ratio of the neon quality that will be when you put it out, it will be neon, will be glowing in the dark. Because neon is a glow in the dark system, especially for holographic vision. So you can see where you're going in the dark. Because the neon color concentration of your radiography ensures that you can distill all the color into an area, and that area will display via polar coders. So the number I got to 25 for. So the ratio I got was 20.54554, which is pi r squared divided by 360. When the radius is 86, and when the luminosity is 86. 86 is determined we use because it's 84 plus 85 is just the share 86. So the luminosity is 86 when the radius is 86. Luminosity of the radius is 86. So the number 86 is basically an angle. So when you get pi over 4 is 16.1355, which is basically times the pi over 4 of 90 degrees. So 90 degrees will give us the number when you divide it over pi r squared over 360. Am I right? Okay. So let me try to calculate again. So if you calculate 86 now, 86 degrees, which is the radius times to the power times 86, which is 82 squared, is 7,396. And then you can do this divided by 360 to give you an area, and that'll be 20.5444 recurring, and that's the number I got. And then this 20.544544 will be times so if I'm working on the perimeter, the surface area of the hue should be emitting, I can do a pi divided by 4 or 2 pi r. So if I do 2 times r, 2 times r, or 2 times pi r, so 2 times pi will be 2 times 86, 2 times 86, and 86 2 times 86 will be 2 times bracket 2 times 86. And that's 172, and that's also 172 divided by 180 will be 2 pi r divided by 2 times r times 180 times pi again times pi, because times pi divided by 180 will give you the degrees of because I just did 2 pi r divided by 180 when the r was 86, and that will give you divided by 180 will give you 61.6 73 67373. Basically, this would be the ratio between point A and point B for the color over the perimeter of the color. Now, this color is very important because you now got to think about the unit pi over 4. So if if the unit was 180, then that is you're working on pi over 3. Pi over 3. So dynamically, this pi over 2, this is pi over 3. So, 'cause, you get to pi over 4, which is 90 degrees. Pi over 3 is 180. And 180 will determine, again, the number is 61, 61, 67373, and this number is unique over 80 because we already predicted on 80. So because we did on 180, if we did on 270, it would be a different ratio. It's not gonna work on different on the axis on that. So this 180 is very important if you did on perimeter. Because the perimeter ratio, because this is just a hard system. But if it's like a growing system, evolving system, you have to have more ratio. You need a dynamic computation table, tabulation table to look at some of the information up. Basically, you need to look up our knowledge, look up of facts and fiction. Basically, I use Lookup table for to look up information over measurement architecture. So you get that system. So you get that here. So that's there. So this number here, 2 pi r times 8. Now we can divide by 4 or divide by 3. Divide by 3. So we now have to do times pi divided by 3, or pi divided by 360, or times pi. But I'm trying to do times because this number is just a units of the system. So I'm going to do times 180, and that 180 should give me the pi divided by 3 because we're in radians, not we're in degrees mode. Times 180. It should give me back. And that's basically the full color of 7. But if I divide by 180, divided by 180, divided by 180 should give me this second. And so this is an R color, so color. So the system here, not preserve. So the next step is just to determine what the luminosity is. The luminosity is basically, if you remember the formula for power, power is what is used. Power, basically power of light. So basically, there's a formula to determine the power of light, and now I used to dynamically determine the luminosity. So let me just find the power, the formula for power in physics. Power equals work divided by time. Power in what? So basically, that means the force of the system, force work equals force times displacement. Work equals force times the displacement. Displacement means the polar axis, and that polar axis has to be the force. So the force of the power divided the work, and the work divided work over time, and that is power. So basically the power will equal the luminosity, which is equal to this. So the power is basically what you're getting used to measure the luminosity, to give you the luminosity dynamically, to give you assuming how much power is being used by the system, to assuming how much power is being to a quantity of a radio wave of a radio system. So the pastel pink is there. So to show that it's there. So that's how that works. So again, it's not rocket science. I got a pastel pink here, but I never applied it. So so the pastel pink is 350 times 180, but the limit is 84. So that means you can multiply to check what the ratio of the pastel pink. Basically, you have to. So if you have a red color red and it dissipates as a wave, it becomes pink. Red, you have to go through some pink variation of the hue because red is very so red, green, region of yolk gave battle in vain. But there's a bit of a pink hue in the red spectrum, which is it's a wave. So if I have a stiletto and it hits the ground and there's a pink wave and there's a wave and a seismic wave, a seismic wave which has meaning, then there's a pink hue in that seismic wave that will dissipate. There's a one point eventually, if the original wave you be zooming pink, and that's the new one position. If I have some kind of stiletto, because I'm using stilettos of some kind of okay, if I have a pet. I'm using the concealer because it's a woman's thing. I'm trying to do one relationship. But if I have a pet, and I have all the red in it, and I have no, and no, I just know what all red, red and all water, red and a bit of water. Just make, and I put the red pipette, and I squeeze the pipette, and drop it in water. The water become pinkish at some point, because it's supposed to absorb the pink. The same thing, which is wave has to use probably as a wave of pink. Okay, that's to propagate as a wave of pink. But I'm saying that's going to happen at some point in time. Hey, don't watch porn in here, please.
I'm watching porn.
No, you're not.
Yes, I am.
Thank you.
So watch.